The UK government, like many governments of the world, has set targets to reducing its carbon dioxide emissions. If these targets are to be achieved both in the short term and in the long term, we must focus on the built environment. In the Solcer Project, we're taking a systems approach and we're combining reduced energy demand with renewable energy supply and energy storage.
A key driver of ours for the Solcer project was to ensure a fully integrated approach was achieved, utilising best practice where possible and pulling away from the traditional one-fits-all approach to retrofit.
The interest from the aspect of GB Sol in being involved in the Solcer project was that we could use the PV as the building envelope. The added benefit that we don't need the cost of replacing the roof because the PV is the roof. We can also add the systems together so that we have battery storage. This allows more of the electricity to be used by the tenant and it improves the level of fuel poverty and makes all of these systems together give one of the most cost-effective ways of upgrading existing buildings.
Computer modelling has indicated that over 70% of energy can be saved at each house for an investment of less than £30,000. This can provide householders with huge financial savings on their energy bills, giving them warmer and more comfortable homes.
At Wales and West Housing, we've made it a priority to target fuel poverty and make our homes more energy efficient. These retrofits give us a glimpse of what the future might look like when we integrate energy generation and energy storage into whole house retrofits.
NPT Homes is the second largest social housing provider in Wales, and in improving the energy efficiency of our properties is high on our agenda. To ensure we maximise the benefits of energy efficiency improvements, we need to understand the benefits that each measure provides, particularly the benefits to our tenants.
It's critical with projects like Solcer when we're installing novel systems and unusual fabric approaches that we're measuring the performance of the buildings after these interventions. So each one of the houses has a monitoring package where we record all of these parameters at a 15-second interval, and we'll continue to do this over the next 2 years so that we have a good idea of the changing impact of the weather conditions and the occupancy patterns on the building's performance in real life.
The Solcer house has been designed as a power station. The house is no longer a simply consumer of electricity, it's now an active generator. This represents a challenge for architects, who now have to move from the conventional architectural design, which focuses on spaces and form, to a more performance-driven architectural design.
We have strengthened our knowledge of a broader Welsh-based supply chain in the low-carbon sector. Also, the on-site solutions for combining supply, storage and demand reduction technologies has broadened our understanding of the areas concerned.
This is where the main power to the building comes in from the national grid through a metering system and initially through a voltage optimisation unit which stabilises the supply and drops the grid voltage down to 220. It prolongs the life of the whole system essentially. From here we're going through an isolator to the monitoring system and distribution board which feeds and is connected to the battery storage and solar PV upstairs. The PV array feeds via 8 strings into a DC fuse board where we concentrate the ampage. From there it's fed through to 2 70 amp battery chargers, which is why it's so different to a standard setup. This enables us to charge the batteries far quicker on days where the irradiation could be quite variable.
Ken and Metalitis work with the LCRI on the Solcer House project here at Park Stormy. We both believe in low carbon technologies, and are striving to promote these in Wales.
What we aim to do in the Solcer project is to demonstrate the performance of these systems in use, to show that we can build them with existing skills, and also to build them at an affordable cost. In predicting the performance of these buildings, we estimate that we can achieve zero carbon performance, if not carbon positive performance. That we can do this in an affordable way. For example, we feel that new build can be approaching the cost of standard build, and that our retrofits are approaching an affordability level.